rational expressions. We get to do a lot with what we did earlier, and factoring, that's going to have a big impact on what we do today. So the two things you're going to be tested on from this lesson, number one, multiply and divide rational expressions. And then the second one, usually significantly more difficult, is adding and subtracting rational expressions. All right, so a couple of things that you need to make sure that you need to know first, and the first one is just kind of a little deal, and that's domain. And so with domain, there's really one important thing to remember, and that is, at least when we have these rational expressions, that the domain is all real numbers. So all real numbers, but the denominator cannot equal 0 for obvious reasons. We can't have a denominator that equals 0. So you'll have a lot of things, and you have blah 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 in the top, whatever it is, but in the bottom you'll have something like this. And you'll get to the end of the problem, you'll do all sorts of crazy math, you'll get it right, but then you just don't get full credit unless you write x cannot equal 2. Because if x equals 2, 2 minus 2 is 0, and then all heck breaks loose. So that's one thing you need to make sure that you've got there. The second thing, the fundamental principle of fractions. Sounds really intimidating, but all it is this. If you have something like a times b divided by a times c, essentially this is just saying numerators cancel themselves out. Or I guess if you have the same thing in the numerator and denominator, it cancels out, and you're left with b divided by c. Now, this is not, absolutely not, if you have something like a plus b divided by a plus c, okay, you cannot cancel these out and have b over c. Okay, this is wrong on so many levels. Okay, so don't make that mistake. You can only do this when we've got kind of these monomials up here. All right, the least common denominator is going to be the kind of one of the big things, especially for adding and subtracting for obvious reasons. And so if I just I'll give you a real simple example here for finding the least common denominator. I know that there's some steps you can follow that, but this is generally speaking how I've always just gone about doing it. So again, well, I'll just give myself a simple numerator and then maybe say something like 4x squared y cubed. And let's say I'm doing something like adding. Again, I'll give myself a simple numerator, 1, and then I've got something like 10x cubed y to the 5th. Okay, so what I think about here is, if I need a common denominator, what can I multiply both of these by to get to the same thing? Well, with the coefficients, it's real simple. I think, okay, least common multiple of 4 and 10. I know you could kind of break it down into its prime factors, but hopefully at this point you're kind of at a level where you could say 20. So the first part of my common denominator is going to be 20. And then for your stuff with exponents, it's going to be real easy. It's just going to be your greatest exponent. So x to the third is the biggest for my x's. So I'll put that in. And then y to the 5th is the biggest for my y's. So I'll just plug that in. Now, of course, the trick here is, what exactly is my numerator going to be? Because I can't just for free turn that into this. If I'm going to keep this whole fraction the same, I'm going to need to do something to the numerator. Well, I think to myself, what did I multiply 4 by to get 20? Well, 5. And so I would have to take this numerator part up here, multiply that by 5. And what did I multiply x squared by to get x cubed? Well, I just multiplied it by 1 x. And then what do I multiply y to the third by to get y to the fifth? Y to the second. Okay. So that's what I multiplied this denominator by in order to get my least common denominator. And so I'm just going to take that and multiply it by my numerator. Now, I picked an easy numerator of 1, so all I need to do for this problem is this. And consequently over here, all I needed to do is multiply this 10 by 2 to get 20. And I've already got x cubed and y to the fifth, so I don't need to change that at all. But if I did have something more complex than the 1, then I would need to kind of simplify those numerators out. And that's kind of my process for going ahead and finding the least common denominator. All right, and then complex fractions. Complex fractions are where we've got essentially, we've got fractions on top of fractions. So I guess a real common example might be something like 1 plus 1 divided by x plus 5. So I've got a fractional expression in the numerator, and then, I don't know, 1 minus 1 over x plus 2. Okay, so these are complex fractions. You kind of want them to be simple to solve, but they're not really. But if you got a couple different methods, and kind of depends on your personality. Do you like to take the long, sure way, or do you like to take a shortcut? So that's complex fractions, and we'll finish the lesson with that. Okay, well, we'll start with a few nice, easy ones. Multiplying fractions, dividing fractions are pretty simple. The first thing you're going to want to do, you see all of this mess up here, but if you remember from what we did the other day with factoring, things start turning out pretty good. So what we're going to do here is we're just going to go ahead and factor each one of these. I was real encouraged by all of your abilities to factor trinomials the other day. So obviously the rigor increases depending on whether or not we would have an a value. None of these do, so I'm thankful for that, I guess. So here we'll say x. We got the negative sign here, so that means I've got 1 positive, 1 negative. Factors of 15 that give me positive 2 would be positive 5. Negative 3. Down here we've got x, positive and positive, so we'll put positive here and a positive here. We want the factors of 30 that give me 11, and that would be 5 and 6. And then we've got the fraction on our right. We'll do the same thing, lots of factoring here. The top one, let's see, again, we've got a case where we've got negative sign, so say 1 positive, 1 negative. Factors of 24 that would give me 2 would be positive 6 and negative 4. And then down here, we've got x. This time we have a positive sign, so it's either positive or negative. And since that's negative, we've got negative. Then factors of 15 that give me 8 would be 5 and 3. We can use that fundamental deal with fractions here and start canceling things out. Because this is multiplication, sometimes in order to save a little space, I'll just say, all right, here they are. They're all together now. And we'll just cross things out. X plus 5 cancels x plus 5. X plus 6 cancels out x plus 6. X minus 3 is going to cancel out an x minus 3. And what I have left is my answer. And that's a very simple x minus 4 over x minus 5. But wait, don't finish there. You need to make sure that you go ahead and say x cannot equal, and then we kind of have to go back to our original thing. It can't be any of these deals. So x cannot equal negative 5, negative 6, positive 5, or 3. And that would be our final answer. Okay, just a real quick division one. You take a look at this and you think, okay, this looks way simpler, and maybe it will be. First thing I'm going to do is I'm going to factor out a 5 from the numerator on the first one. So I've got 5, and that'll leave me with x plus 5. Kind of hoping I get another x plus 5 somewhere around here, divided by 10. And then over on the right, I can factor out a 6. And that'll, hey, look at that, another x plus 5. Fantastic. Divide both sides by 12. All right, at this point, I notice that, hey, 5 and 10, that'll reduce, as will 6 and 12. So I'm going to rewrite this as x plus 5 over 2, and then divided by, we'll say x plus 5 over 2. Well, anything divided by itself is going to be equal to 1, so I kind of have a suspicion that this is just going to equal 1 in the end, but if we want to go through the process, we could just say x plus 5 divided by 2, and then remember when you're dividing fractions, it's same, change to multiplication and flip, or invert and multiply. So we're going to say 2 over x plus 5. And hey, what do you know? Things start canceling out. And it's not this equals 0 now, it's just that you essentially just have 1 over 1, which is equal to 1. And we're done. All right, moving on to adding and subtracting. This is where it starts to get a little bit hairy because you have to find that least common multiple. And so, kind of like from the one before, I look at this and I think to myself, all right, what do I need to multiply each of these by in order to get that common denominator? And I know that if I multiply 9 by 2, I'm going to get 18. So 18 is my least common part for that right there. And then a cubed is my biggest a, and b squared is my biggest b. So a cubed and b squared. So there's my least common denominator. But now, what did I multiply the tops by? Well, over here, I didn't have to multiply it by anything, so it's just 7. Over here, I had to multiply the top by 2, because I multiplied 9 by 2 to get 18. I also had to multiply a by a squared to get a cubed. Now I had to multiply b by b to get b squared. So I'm going to have this times the numerator. Multiplying these out, I'm going to get 4a squared b. And, well, now that I have the common denominators, I can just kind of pour it all together, and I've got 7 minus 4a squared b divided by 18a cubed b squared. And, of course, we have to just say that a cannot equal 0, and b cannot equal 0. Because if they are, the whole thing goes to 0. And that's it. All right. Let's go with a slightly more complex version. And dealing with subtraction this time. All right. So this one, here's how we're going to start. Let's move this up, give ourselves a little bit of room to work with. Get my pen back here, sorry. All right. So we've got m minus 4 divided by 3m minus 4, and then minus 5m divided by 4 minus 3m. So the very first thing that I'm going to do is I'm going to go ahead and just try to see if I can work out some sort of common denominator. Sometimes what'll happen, you notice these kind of look like each other, but not quite. So what if I kept this 3m minus 4, m minus 4 in the numerator? But then over here, what if I just kind of converted this to, well, what if I said negative 3m plus 4? Well, that looks a little bit more like this denominator over here. And in fact, if I factor out a negative sign, I can make this negative positive 3m minus 4. And now, hey, look at that. I have the same thing here. And so the other thing I'm going to do is I'm going to just kind of cycle this negative sign back up here. And that's going to make this m minus 4 over 3m minus 4 plus 5m over 3m minus 4. And this we're pretty happy at this point. And so we're going to say this is, put everything together, we've got m minus 4 plus 5m, and then divided by our common denominator, which just kind of worked out for us, 3m minus 4. Not quite done yet. We can combine some like terms here. We've got 6m minus 4 over 3m minus 4. Notice that I can factor out a 2 from that top one. So I've got 2 times 3m minus 2 and divided by 3m minus 4. And, well, that's it, except we need to remember that we have to say, well, what can m not equal? Well, if I said, all right, 3m minus 4 equals 0, because remember, I don't want the denominator to equal 0, so it's kind of counterintuitive, but I'd say, all right, 3m equals 4, m equals 4/3. If m equals 4/3, then the denominator equals 0, so I'll now say m cannot equal 4/3. All right, and there we've got a final solution. Okay. Now, example 3, the complex fractions. So I prefer the method where we're just going to kind of, it might be a little bit longer, but it's kind of the sure thing. So what we're going to do is I'm just going to take the numerator right now and just work with that. If I find the least common denominator, well, then I'm going to have 2x plus 1 and x plus 1 on the bottom. You can see that I've just turned this 2 into 2 times x plus 1 divided by x plus 1. These would cancel out. I'd still just have the 2. And then over here in the top, I'm just going to keep 2 over, 1 plus x. Probably just keep that 1 plus x over there. All right, but now that I have these common denominators, I would have 2x plus 1 plus 2 over my common denominator of x plus 1. And then combine some like terms here. I had 2x plus 1 plus 2, so now I've got 2x plus 3 over x plus 1. All right, so that's what my numerator looks like when I take care of that. But now I want to take care of the denominator. Oh, sorry, this is 2x plus 2. So I would have 2x plus 4. I've got a few distractions in the room here with me. All right, and now I'm going to take a look at the denominator. Okay, so again, same process. I'm going to say 2 and then kind of multiply this by 1 minus x on top and 1 minus x on the bottom. So that'll turn that 2 into something that has a common denominator with the rest of this stuff. 2 over 1 minus x. All right, so distributive property over there on the left, I got 2 minus 2x, and then minus 2 from the right, all over 1 minus x. Combine some like terms, 2 minus 2 is 0, so I just wind up with negative 2x over 1 minus x. All right, so I've got this is my numerator, this is my denominator. I'm going to kind of put it all together now and say kind of the whole same change flip thing. I'm going to keep this 2x plus 4 divided by x plus 1. Change the division to multiplication, and then say 1 minus x divided by negative 2x. Now, nice thing here is that this is multiplication, so that makes things significantly better for my life. I'm going to factor out a 2 out of this guy on the left, so that'll be 2 times x plus 2. And then I've also got this 1 minus x hanging out on top. And then down in the bottom, I've got a negative 2x times an x plus 1, or I think 1 plus x might be how it was originally, but it's okay, it's the same. All right, well, that fundamental property of fractions says that these can cancel themselves out. And I'm now down to my final glorious answer. X plus 2 times 1 minus x divided by negative x times x plus 1. And what are the things that x cannot equal? Well, x cannot equal 0. If it equals 0, that whole thing goes to 0. And if x equals negative 1, then that whole thing goes to 0. So, not impossible, but quite a few steps. All right, that's it. Hope you've enjoyed